Should be good.
Okay, thanks, Kyle. Appreciate it. Thanks everybody for coming out. Really appreciate you being with OWASP and being a part of the community. It's as we'll see along the way, we got a long way to go in AppSec. So thank you for participating. This is the most exciting time in the history of AppSec by a lot. We'll talk a little bit about why, but this is a very exciting time. I started in AppSec, I was a programmer for a while, and then I started in AppSec back in the late 90s. I was really fortunate to help start one of the world's first consulting groups focused all on AppSec. Got to secure some of the companies in the dot-com boom and started one of the first consulting companies in AppSec. Around that time, I also helped to start OWASP. So it was just a mailing list in those days, by the way. Joined the mailing list, started participating. We had a kind of cool community, and I had a few projects that I've been working on, one of which was WebGoat. Anybody heard of WebGoat? Yeah, so I wrote that in like 1999 and contributed to OWASP in 2001, and it kind of took off, and I liked it. That was my first open source interaction. And I thought it was really exciting. Like, people loved it. They were playing around with it, learning about AppSec, and I was like, wow, this is good, and it was good for my company, which is really interesting. Like, participating in the open source community is really good for business. So that's the lesson I took from that. And we started contributing to OAuth quite a bit. I had this idea, I was going into government agencies and talking to them about AppSec, and I was getting a little bit of the stiff arm. They're like, okay, we're working on the OAuth we're working on the SANS top 20 right now. This is 20 years ago, a little over 20 years ago. So I almost said, like, kid, we're working on I'm old now. But so it was, I had this idea. I came home, I was like, damn it, we need a top 10 list. So I wrote the first OWASP top 10 and put that out there. And that thing took off like crazy. We got slash-dotted, took down OWASP. It was the early days of OWASP were kind of a circus. Our servers, I think the statute of limitations is probably run. Our servers were like under some guy's desk in a data center provider. Like, he was like, then we moved inside a cage of some customer, and we were like, just, I don't know, stealing their access to the internet. Eventually, that company went bankrupt, and the data center company seized our servers. They took OWASP, and I was like, I called them up. I was like, oh man, look, big misunderstanding. Sorry, we're not the bad guys. We don't have any money. We're an open source, charity. Like, we're having fun. And they were like, well, sorry, you can't have your servers back. I was like, all right, screw it. We started over, threw everything away, and I decided we were going to go to MediaWiki. We used the wiki for a long time. Now it's on GitHub, which I think is really cool. So anyway, the long history in AppSec. I've worked with hundreds of really large companies on their AppSec programs. I've built tools. I've contributed made a lot of open source projects. And today I'm the CTO and co-founder of a company called Contrast Security. We have a sort of a unique platform for doing runtime security, which we're going to dive into today. And I hope that you leave this with an appreciation for how our tools drive the AppSec practice that you implement. There's it's like, if you're digging holes in the backyard with shovels, you've got a certain process, certain set of procedures, certain teams. If you're doing it with a bulldozer, very different process. So I want you to think about the relationship. People always say, well, people first, then process, then technology, and they're all really interlinked. So we're going to dive into what runtime security can do. Quick quiz. Anybody know where cybersecurity ranks on the World Economic Forum's list of global risks? Actually, you're totally wrong. It's number 4. It's right after, extreme weather and interstate armed conflict. We're ahead of armed conflict, which is crazy. This is really important stuff. that we talk about, that we do. AppSec is not just, like a little offshoot. This is all software, by the way. 99% of CVEs and security vulnerabilities and attacks, they're all software, whether it's, product-based, in an operating system or a firewall or something, or it's application-based, like the kinds of things that we deal with, web apps, web APIs, things like that. It's all software, and it's really important. So I think that's, if you really think about the risk that this presents to the world, this is an important thing that we do. Who here banks online? Right? Anybody use government? Anybody have healthcare? Anybody power? Anybody use power? Anybody participate in elections? All this stuff is software. This is really important. What we do every day, secure the apps that make these things possible. And we all rely on this. I guarantee you've used apps today hundreds of times, whether it's, the ones that are controlling the traffic lights or in your car, or, there's software everywhere, and we suck at writing secure software. We are really bad at it. Well, they'll let anybody in here. Good to see, man. So I'm going to talk a little bit today about fundamentally why we're bad at writing secure software. By the way, the governments of the world have started to take notice of the fact that we suck at writing secure software. If you look at some, from the executive order, and I think this is great. The executive order is exactly called out the problem. They said, hey, we're not good enough at writing secure code. We need to put security in place that is proportional to how trustworthy and transparent that infrastructure is. And incremental improvements will not give us the security we need. That is absolutely right. When I started in AppSec, we usually found about 25 to 30 vulnerabilities per app, somewhere in that range. Things like SQL injection, cross-site scripting, file path traversal, things like that. Today, after 20 years, over 20 years of having the OWASP Top 10 and OWASP and all the things they do, and I'm not denigrating what OWASP has done. I think there's been some great research and some great projects there, but we haven't made a damn bit of difference. The number's the same or worse today than it was 20 years ago. With the same problems, it's still SQL injection and path traversal and authentication and authorization and encryption and all that stuff. That's nuts. That is absolutely nuts. That is not just, we don't have the right, regulations in place. There's a fundamental problem in the market. But the cool thing is the governments have focused on transparency. Why is transparency the right approach here to fix the market? Yeah, I think there's something about that. But being transparent is more about just you knowing about it. It's about everybody knowing about it, right? And so I encourage you to read this paper called A Market for Lemons. It's by a guy named George Akerlof. He won the Nobel Prize for this 40, 50 years ago. And what he said in there is, in certain markets, there's information asymmetries. The buyer doesn't have all the information that the seller has. So he wrote a paper about the used car market, the market for lemons. And what he said was, in markets like that, when the buyer doesn't have enough information, they have to discount the price that they're willing to pay for a used car. Why do they discount it? Because they don't know if it's a lemon or not, right? You don't know what you're buying when you buy a used car. So you're not going to pay full price for a used car because you don't know. It might be a piece of junk. So the observation that he made was, yeah, that's true. You won't pay full price. But what it also means is that people with good cars won't sell them in the used car market because they can't get full price. And so what does that make the used car market? Full of lemons. Exactly right. It's all lemons. I believe the software market is a market for lemons. You can't really build secure software and get full value for it, so you don't sell it. And what we see is most companies are barely doing the minimum. How many companies do you know that have a backlog of application security vulnerabilities? How many in the hundreds of thousands or millions? I know a lot of them. It's not like we're doing the job, okay? So that's what has to change. And I think transparency is the path forward. The remedy for a market for lemons is to make it transparent so that both sides have the same information, okay? So that's why they're mandating things like S-bombs is just a toe in the water, by the way. It's cool. It's not going to change anything, but it's at least a toe in the water for transparency, which is the goal, in my opinion. But they're forcing companies to be transparent about things like, are you doing basic application security? There's even an attestations rule that companies are going to have to attest to the fact that they did basic application security stuff, like, did you test your software? Did you fix the vulnerabilities? Do you have runtime protection in place? Like that kind of thing, basic stuff. The analysts have also figured out that there's a problem. They take a different approach. They're going to make more acronyms. That's going to solve the problem. Does anybody know all of these acronyms? Right, exactly. There's all. What's funny to me is that all of this is about two things. It's about finding vulnerabilities and preventing exploits. That's it. All this. So, you know, like there's some things on the side of this, like that find vulnerabilities, the AST ones on here, and then there's the ones about stopping vulnerability exploits, things like WAF and RASP and things like that. And then there's a number of these. I think this is kind of funny. There's a number of acronyms up here, whole categories of things that are just designed to manage the data coming out of the other things in here, right? Like all the SPMs, those kinds, and the ASOCs and things like that. So this is just crazy. This is not helping, because nobody could buy all of those products and manage all of them, even in a big company. Like it's too much. So that's not going to help anything. Acronyms aren't a strategy. So fundamentally, why is AppSec so hard? One factor is that it's a massive problem. So over here on the left is a stack of paper. It's about 30,000 pages. It's the US tax code, all of it, right? And imagine you're a lawyer and your job is to find loopholes in the US tax code, or a team of lawyers. How long do you think it's going to take to go through the whole US tax code and get that? I will share, there's a question. I will share the presentation. So that's a hard job. It's very similar. Side note, I did graduate from Georgetown Law School. I don't practice law, but I thought I was going to do that for a while. But anyway, I know a lot about contracts. And reviewing contracts is like reviewing code. I've also done a shit ton of code review. I really like manual code review. I'm kind of weird that way, but it's not that dissimilar. It's a specialized language, it's got terms of art, it's got subroutines and modules and so on. And finding loopholes in the US tax code is hard. This is the amount of code in one application. You printed it out. This is the, that's just the custom code. This is the amount of code if you include all the libraries and frameworks and all that stuff. And this is the amount of code in a typical large enterprise. It's almost up to the US space station. It's really hard. And this is all changing all the time. New versions of libraries, changes to custom code, new apps. Nobody ever retires anything, but a few retired apps, like it's always changing. It's a really hard problem to manage that kind of thing. By the way, that's Klay Thompson for the Golden State Warriors. He's my height. This is the whole champion Golden State Warriors team from a few years ago. So it's probably, I don't know, 6, 7 times 5, like 40 feet tall, something like that. Anyway, so securing software used to be much simpler when I started in AppSec. The early days were really fun. Found the same vulnerabilities in every app. You almost didn't have to. Yeah, you got XSS, you got SQL injection, you got path traversal, you got some direct object references. I made up that category then. And it's gotten a lot more complex. Software has gotten increasingly fragmented. So there's lots of pieces of code, multiple different repos, tons of libraries, APIs, microservices, all interconnected. So it's gotten much harder to understand an application. And we used to try to protect them with firewalls and scanners, but those tools haven't progressed. Firewalls are a network device. They look at network traffic, web app firewalls, and don't really have the context of what they're protecting. So it's very difficult. I mean, even looking at HTTP traffic today as a human, you can't really figure it out. We could 20 years ago, but today it's all XML and JSON and serialized objects and WebSocket. It's really difficult to decide whether something is legitimate traffic or not. Web app firewalls, that's why they're so easily bypassable. We need to do application security differently. And scanners like SAS tools and DAS tools are also not very effective because they don't have the context they need to make the right decision about whether something is really a vulnerability or not. I'll give you an example. Most static tools don't analyze the libraries. They just analyze the custom code. And they make assumptions about what the libraries do. Well, a ton of that code, we'll talk specifically about exactly how much, but a ton of that code is libraries. And if you're missing big chunks of the picture, you're not going to get a good understanding of how the code actually works. So you're going to make a lot of mistakes. DAS tools, also really difficult for a DAS tool to understand how to navigate an application, how to traverse the code. And to identify a vulnerability, they have to successfully exploit it, which is hard. Maybe some of you have done pen testing and tried to figure out exploits for vulnerabilities. They're almost all tricky, right? They're all quirky. There's a weird thing that you have to do to get it to work on that app. Well, DAS tools may easily miss it. So we're not in a really good place. And so I would say for the most part, most organizations really don't have a good idea of whether their code is secure or not. We've ended up in this world where traditional AppSec just isn't really working very well. This is software development process, looks great. If you read a lot about DevOps, and you should read the Phoenix project. If you haven't, you really should. It's a great way to understand how DevOps changes software development. But even if you're doing that, the non-security view is great. You can pump new features into production really fast. You can do it, from developer to production in 10 minutes through the CI/CD pipeline. Well, security is not designed for DevOps. Even though a lot of people try to sound like their product is DevOpsy, it's really not. Like most organizations, they run a bunch of these different kinds of traditional tools. And these tools were invented at the beginning of OWASP. These are tools from 2002, 2003, and they haven't really kept up. And they do two things. One is they slow down the process because a DAS tool can take many hours or days to run, depending. SAS tools can take a long time to run, and then they generate so many false positives. If you got to triage it, that's part of the process. Like you can't go to production until you triage those. So it's difficult. And so what we see over and over in lots of organizations is they run this process and they generate a lot of vulnerabilities that go into a backlog, and then they sit there. And somebody has to comb through them to decide whether they're going to fix them and pick them up in a sprint. And the average time to fix a vulnerability found with static analysis, anybody know? Anybody take a stab? It's not quite forever. Might as well be. More than 2 months. It's actually 290 days on average. That's crazy. That leaves you vulnerable for 3/4 of a year. DAS is actually worse. It's 315 days. That's not what we're looking for. That's not going to get us there, right? And what's weird about that is that it doesn't create any learning. What you really want is a fast feedback loop. That's like there's in the Phoenix project, there's 3 principles of DevOps. Number 2 is fast feedback loops. And that's what we need to make this work. We've got to have fast, accurate feedback to developers so that there's learning. That's the 3rd principle in the Phoenix project. And if we can learn, we can start reducing the rate of new vulnerabilities. average rate of new vulnerabilities is like 4 or 5 a month per project. And those start piling up really quickly. If you don't fix them, you're piling up vulnerabilities on vulnerability. So this is broken. It's not DevSecOps, regardless of what people say. If you actually thought about, let me say it this way. DevOps is about changing the work that developers do. It breaks it down into small pieces, it makes tight feedback loops, and it creates a culture of experimentation and learning. Those are the 3 lessons from the Phoenix project. And security has not made that jump yet. This is not breaking down the work into small pieces. This is not creating tight feedback loops, and it's not creating a culture of experimentation and learning. We haven't transformed the work of AppSec yet. So I think that's what has to happen for us to succeed at it. That's why I keep saying we're in sort of the stone age of application security. Even though it's been 25 years for me, there's a long way to go. So I encourage you, if you've got entrepreneurial spirit or you just want to be in the beginning of something, it's important, and we're terrible at it. So it's a really good time, because I don't think there's only a few things that are more important to the future of the planet than this. All right, so let's talk about runtime security. Now, when I say runtime, I don't want people to get confused and think production. Runtime is the opposite of compile time. We got some developers in the room, I know. Compile time is when you've got source code building into a binary. Runtime is when you actually invoke it and it runs. You could run it in development, run it in a QA environment, or you could run it in production. So runtime is orthogonal from development versus production. Everybody with me? Okay. Some people make that confusion, and it messes up the conversation. So I'm going to start at the very beginning, and we're going to build up. So let me just check my time here real quick. So the root cause, in my opinion, of all software security problems is dangerous, unprotected functions. These are functions like the method that sends a SQL query to the SQL database, or the method that starts a native process, or the method that parses an XML document, or deserializes an object, or hashes some data. All those methods are dangerous because they do something powerful and important. There are thousands of these in the typical software stack. A bunch of them, like I'm mostly a Java guy. I've done a lot of work in a lot of languages, but mostly I'll use Java examples because it's natural for me. In the Java stack, there's the stuff that comes with the JVM, the Java runtime, thousands of methods in there. There's a ton of methods in the app server, like Tomcat or whatever, Gasfish or whatever you're using. There's a ton of methods in the framework that you're using, like Struts or Spring. There's a ton of methods in open source libraries like Log4j. And there's a bunch of methods that are potentially dangerous in your custom code. Thousands of methods. They are at core, these are what cause almost all vulnerabilities and breaches, is those methods being misused by a developer. And the problem is there's no documentation, there's no compiler warnings, there's no attack detection and no exploit prevention. Those methods are like Bambi in the wilderness. They're just sitting there just waiting to be shot. This is runtime.exec in Java. No documentation that says, don't call this with untrusted data. Nothing. There's no checks in here to say, hey, if untrusted data gets in here, throw an exception or give me a warning or something. And there's nothing here that stops an attack that's, an obvious attack that's like, hey, start a native command and install ransomware, whatever. So this virtually guarantees vulnerabilities, right? Thousands of methods, millions of untrained developers. At best, OWASP is the biggest trainer of developers in secure coding, and their big, hairy, audacious goal is to train like 5,000 a year. So we're way out of proportion on this. So here's just a few other examples of methods that are super dangerous. I won't go into the details, but every vulnerability, everything in the top 10, everything in ASVS, everything in this, all the standards around application security, anything technical, you can trace it back to the methods that are responsible for it. There are a lot. It's not just one language. It's actually all the different languages, Java, .NET, .NET Core, Node, Ruby, Python, Go, Kotlin, Scala, PHP. They've all got a big platform. And there's multiple versions of all those things. So it'd be great if we could fix these, right? Like, hey, maybe we could start fixing them. We could go to these projects and start talking to them and get them to change their code so they be better documented, give us some warnings, developers wouldn't misuse them, and awesome. Well, I tried that. It was one of the most frustrating experiences of my life. I joined the Java servlet spec team, maybe, I don't know, 15 years ago, and I worked with them for 7 years. And I tried, my whole mission was to try to do exactly what I said. Like, let's just get some documentation that says, hey, if you're gonna make a new cookie, maybe turn on the secure flag. Just simple things to prevent XSS and other things, related to the servlet spec. Well, it was really frustrating. Massive pushback. Every objection in the book. No, it's a performance problem. I wrote a bunch of test cases and I showed you it's not a performance problem. Well, we're not going to do it. So I managed to get a couple of things done. Like null byte injection is now not impossible. It's now not possible in Java, in file names, because I got that change made. Can't use a null byte in a file name because we made it illegal. But there's very few victories, and it was really painful. So now try to imagine that across all the new frameworks. And as soon as we did it, somebody would say, well, this framework's too cumbersome now. We're going to make a new framework that's more streamlined. And that's kind of the cycle that, you start a new framework and it's awesome. Everybody moves to it. Then you start adding security in and you clunk it all up with security. And then someone's like, we need a new streamlined one. It all happens over again, over and over. So I want to talk to you about instrumentation. Instrumentation is what we do when things are complicated. We instrument our cars, right? You got all kinds of flashing lights in your car because it's instrumented. Instrumentation in, what else? What are some other examples of things that are instrumented? I think I use that example all the time. Absolutely instrumented to the nines. Yep. What else? That's right. Anybody wearing a Fitbit or an Apple Watch? You're instrumented. Almost everything's instrumented. Industrial factories are an incredible example. They're instrumented like crazy today. Everything is instrumented for vibration, fire, temperature, sounds, everything. Because they want to know if there's a problem before there's a problem. That's what instrumentation buys you. And so this is an instrumented basketball. And I got it. It's cool. It measures your dribble speed, the arc of your shot, makes and misses. It's got an app. It gives you drills, a bunch of stuff. And what I realized was, by the way, it fixed my shot. Like I became a much better shooter because I realized like it corrected the arc of my shot. It's fantastic. But what I realized is that instrumentation changes whole industries. If you gave these to your basketball team and let them practice and improve on their own, the job of the coach changes. Now the coach doesn't have to run everybody through the same drills. They can look at the data and they can strategically coach the places that need it to improve the team. It changed the economics of basketball coaching. And it does the same thing for doctors. Anybody starting to use like telemedicine, like get an online doctor appointment? You can have your doctor monitor your condition the whole year. Instead of having to walk into the office and go like, are you showing the symptoms right now? No. Okay, well, go away. Instead, they can monitor, like you've got my daughter has tachycardia, heart. It's a fast beating heart. And she'd have an incident. We'd rush her to the doctor, it'd be over. They'd be like, well, you got to bring her in when she's having a thing. It's impossible. So we got her a watch kind of thing, monitor it. Now we've got data. Took it in, she got the right treatment. This changes everything. It changes public health. I mean, massive scale public health. If we've got an epidemic You want instrumentation across your people because your phone is likely to know that you're sick before you do. So why do I bring this up? Software instrumentation is really powerful. We can instrument our software separate from writing. You write the app, you build it, you run it, you've got great code, but we can instrument it later. Google Analytics is a good example of how you instrument a website for marketing purposes. You can see exactly who clicks on what order they click on stuff, where traffic's going, where people aren't clicking, do A/B testing, all kinds of stuff. On the server side, you can instrument code pretty easily. This is a typical architecture, but the idea is you've got the original binary on disk. And normally it would load straight into memory, and it'd be an exact copy of the code on disk. You just put it in memory and then you'd start running it. But instrumentation allows you to hook that process, and you can add security checks to the code as it loads. So the transformer adds, well, I'm going to call them sensors to the code, and then you run the instrumented code. So I thought this was really cool. In 2009, I wrote a paper for Black Hat about what a malicious developer might do inside a big company. And I was like, wow, if they could use this for evil, it'd be really bad. They could put a backdoor in the application, exploit it, and then pull it out of the application, and it'll just gone. But it started me thinking, like, is there a way we can use this for good? And when I put it together with this idea of dangerous functions, the answer became clear. We can instrument these dangerous functions. So imagine we could put checks directly into those dangerous functions. Like, here's a little dangerous function. We can inject security checks right into it that can do really two things. We can prevent developers from using those methods unsafely. This is pretty easy. If a developer sends untrusted data into a SQL statement.execute, we can immediately identify that and give them a warning back that says, hey, here's the exact stack trace, here's the exact code, here's the data, here's the HTTP request, just all the data you need, and you accidentally passed in some untrusted data into this method. You can't do that. That's bad. So that's a instant feedback loop. That's what we're shooting for. And then in production, we can prevent attackers from exploiting those same methods. So that same security boundary here can detect this attack and prevent it from exploiting the function. So if the attacker sends in, or 1 = 1, those checks can identify that and say, hey, that modified the meaning of the query. Let's stop that attack and prevent it from going to the database, so we stay safe. We didn't need any firewalls. We didn't need any scanners. This is just built into the software itself now. This is how we can solve whole classes of vulnerabilities very accurately and very fast. Yeah, question? Yeah, that's right. So in development, you don't care about the impact that much, right? Because you're just running your tests or whatever. It's actually really fast. Like, it's a few milliseconds on a round trip request in development. In production, it's even faster because it's more optimized in production, sub-millisecond. So faster than a WAF in production. But there always is going to be some kind of performance impact to doing security checks, whether you use a WAF. I mean, I guess, do we have agreement that we should detect attacks? So once you decide you're going to detect attacks, then it's a matter of how you're going to do it and how can we do it the fastest. If you put that detection in a box on the network and say that your checks are going to be, you have to pass this list of 10,000 regular expressions, that's not the most efficient way to do it. If you put it right in the code, right in the method that already has parsed the HTTP request, it's done all the work, all you have to do is check to see if it modified the meaning of the query. You can do that really fast. So that's the theory here, is let's put the security right where it belongs, right in the methods that need it. So here's how it actually works. Hopefully you can read this or at least understand it. So that's the execute query method in Java. No security checks at all, no documentation or anything. So what we're going to do is we're going to shove a new line of code in there that says, like, hey, we're going to enforce a SQL injection boundary here. And what that does is it does those two checks. We're going to check to see if it has untrusted data, and then we're going to warn the developer. If it contains an attack, we're going to throw an exception and and report it to so that we have a history of who's attacking what. But this is very lightweight stuff. It's not big, heavyweight, complex security code. This is just putting the right check in the right place surgically inside the application. And the cool thing is, instead of rewriting those hundreds of thousands of libraries that are out there with dangerous functions, we can do it automatically with instrumentation, so that we can just keep a big list of what the dangerous methods are, and we can just push the right checks into those methods. So this is kind of how it works, across a bunch of methods. As your stack loads those methods, we can inject these trust boundaries into those dangerous methods. This is once this happens, then it's almost invisible. You just do your normal development process. No code changes, no scanning, no scheduling, no hacking. You just do your normal development process, and the vulnerabilities will get reported to you automatically. You don't have to do any work. You don't have to know anything about security. And now security it's just a normal part of the way that you build, test, and deploy your code. So this is just a slide showing it's putting security in the right place. Instead of trying to secure 1,000 SQL queries in your application and rewriting the code to do them, maybe you parameterize them or escape the data or whatever. That's hard. It's hard to get developers to do it right. By the way, the last time I looked at it hard, there's a 40% failure rate on security fixes when you retest them. I mean, you give the developer a direction, say, hey, there's a vulnerability there. Here's what you need to do to fix it. They don't do that. They do something else, and they don't get the fix right. But if we put the fix in the SQL library, the one right place, it's much more efficient. So this is how zooming out, the whole big picture. This is a really effective way of doing security. You just add runtime security to your platform. And by the way, we're not it says contrast there. I tried to change everything here to say runtime security. We're not the only runtime security company. I'm trying to explain the technology. This is not a sales pitch. I just want you to understand how this works. But add this to your platform, whether it's your standard container or your gold server or your deployment script, however you deploy the code, add contrast to that, or runtime security to that. And then as you use the application during dev and QA, you'll get instant feedback on vulnerabilities. You can fix that. We've seen this reduce mean time to remediate to less than 3 days on average, and many big companies, including BMW, are now less than 1 day across thousands of developers. 1 day security remediation for AppSec vulnerabilities. Then in production, we're protected. So you might say, wait a minute, Jeff, why do we need to do both of these things? If we fix the code, then we're good, right? We don't need to protect in production. Anybody buy that? No, why not? Even if you were perfect over here, there's still new CVEs that come out. There's vulnerabilities in libraries. There's stuff you don't control. And so I think having both of these in place is the right solution. And you're not going to it's going to take a while to fix your backlog of vulnerabilities. Even if you discovered them all in a day and it was all super accurate, it's going to take a while to work them on. So this is runtime protection. This is runtime security in development. And it's really effective. I've got some slides. Here's just an example on SQL injection, just so you can see. On the development side, developer just gets instant feedback as soon as they test their code. And notice all I did was type in Jeff, and I found the vulnerability. I got it back immediately. I make the right fix, and I check in clean code. In production, the attacker sends a SQL injection attack. Immediately, when it hits this method, it gets detected and blocked and reported. One thing that's interesting is a WAF can only protect the front door, but runtime protection protects attacks that come from other connections into the application. What if this came through MQ into the application and caused SQL injection? Apps are really complicated now. There's not just a front door. There's all kinds of other data coming in through APIs, winding around, and eventually getting to some code that might have SQL injection in it. Well, runtime protection stops that too. So I think it's a different kind of protection. It puts the protection where it should have been in the first place, but the world is the way it is. We got hundreds of thousands of libraries with vulnerabilities in it. We got to deal with that. Okay, so that's runtime security. I wanted to talk for a minute about how this affects open source security. So we monitor hundreds of thousands of applications, we've instrumented them, and we measure how the open source is actually used in the application, right? Because we watch it run. So we can see open source as it gets called, and it's kind of cool. 62% of libraries are never invoked. They never even load into memory. So this part of the iceberg, you'll hear people say this stat like 80% of applications is open source software. That is not true. At least if you care about the code that actually matters. 80%, this 62% of libraries never loads and presents zero risk to your applications. So I want you to focus on the code that matters. That's the code that runs, and that's that pink part at the top here. Most of it is custom code. About 2/3 of it is actually custom code, and about 1/3 is open source. This surprises a lot of people. But when you actually measure it, that's what we see, is about 1/3 open source code. And look, open source is super important. There's been some big vulnerabilities, but I actually think the bigger, more risky vulnerabilities are here in custom code. You got to do both. And one thing I think is really important is, or maybe it's a little silly, is that people are analyzing custom code and libraries separate from one another, right? You run a SaaS tool on your open source, on your source code, and then you run an SCA tool on your POM or whatever and analyze your libraries. That's a little crazy because I can count on one hand the number of vulnerabilities I've found that are like completely contained within a single piece of code. It almost always spans open, like typically a request comes in, it goes through a framework, gets some custom code, maybe bounces back and forth a few times into open source libraries, and eventually it hits one of those dangerous functions. So I want you to see the whole picture. One of the big reasons that static analysis tools make so many mistakes is that they can't see the whole picture. They're only looking at this little piece up at the top, and they don't see how all these libraries are actually built. Make sense? So and it explains kind of the phenomenon we've seen. Like only 5 or 10% of vulnerabilities of CVEs in open source libraries are actually exploitable. It's not just the fact that some of that code isn't used. Some of those open source libraries, there's conditions on whether you can actually exploit the vulnerability. Like, was it configured a certain way or things like that. So, I want to try to raise awareness about this. I want you to focus on the code that matters, which is the libraries that actually run. And knowing that those libraries run will dramatically simplify your open source security picture. So there's a few different ways of analyzing open source. You can run an SCA tool on it. Typically, this just looks at your POM or your build file or something. It's got some problems with identifying things that are build and test libraries, platform and server libraries. Those aren't in the repo, right? Those are in your stack. They're really relevant to security. Lots of libraries there, and that's why people have had so much trouble tracking down log4j. There's also a bunch of hidden libraries. Most apps load libraries dynamically. They load plugins. Those things aren't in the build file. But we see them at runtime. So what I'm encouraging you to do is, it's great to get a picture of what libraries look like in development. That's fine. But you should also get a picture of what your libraries look like in production. As the application's running, this will show you what actually is used. It'll show you libraries that are hidden from your process. So you get a different, it's not more accurate necessarily. It's just a different view, but this is like more relevant to making risk decisions, is looking at what libraries actually run. Here's just some CVEs that Runtime Security prevented And this is interesting. We prevented these vulnerabilities from being exploited before they were discovered. Like we started preventing, struts and spring vulnerabilities years before those vulnerabilities were detected, because we make things like expression language injection and unsafe deserialization. We make those whole classes of vulnerabilities unexploitable. We're also, so in addition to solving a bunch of CVEs, we're also taking away some tricks out of the attacker's bag. One of the things attackers love to do is use reflection to invoke the class loader, and then they can get code to load that they can then run, which gives them remote command execution. If we take that capability away, say, hey, you can't use reflection to access the class loader, then they can't do that. That's a major trick that attackers use, and we just took it off the table. Developers don't need it. They have always regular access to the class loader. So that's been really effective at stopping a bunch of things. So some outcomes, like I mentioned before, technology can change the way that people do business. We're working with stone tools in AppSec, and we can transform the way that the operating model of application security to something much more streamlined by taking advantage of the power of instrumentation. We can, so I talked earlier about the relationship between the coach and the players. We changed the relationship between the AppSec experts and the developers. We can empower the developers to do most of this themselves, and the role of AppSec becomes much more strategic. Wouldn't you rather spend your time doing things like threat modeling and security architecture and threat intelligence than things like tracking down whether a reported XSS was a false positive or not? That doesn't benefit anybody. That's what we're trying to do, is change the math of application security so that it actually works. Runtime security, so some things we can deliver. Unified tooling, one tool to do all the stuff in AppSec. I'll talk a little bit about this security observability. You can get a detailed security blueprint of every application. Runtime protection, we talked about that. Vulnerability prevention, helping developers prevent the vulnerability from existing in the first place. What you really want is not to build up a big backlog. You want to prevent vulnerabilities from getting into the system in the first place. Eliminate it before it becomes a problem. And continuous compliance, like this runs continuously in the background. So we've had really good results with this. Like I said, reduced remediation time to 3 days on average. What you want to see is a curve that looks like this: found vulnerabilities and fixed vulnerabilities. You want it to catch up, and you want to get to a really healthy place where these lines are close together. But in most organizations, it looks like this. You're finding more than you're fixing, and it's getting worse over time. That's why people want to throw this. I don't think ASPM fixes this problem, by the way. It's just a bigger, nicer haystack. I think of this a little bit like the scene from Cars where Doc Hudson tells Lightning McQueen, you got to turn right to go left. There's a whole bunch of people out there talking about shifting left. The problem is, if you shift all the way left, you lose all the context. And so you start generating tons of false positives, and you end up in backlog world. So I'm encouraging you to think about shifting to runtime, getting that context, getting really accurate results, and then using that context to focus on the things that actually matter. That actually achieves the goal of shifting left. It's a little bit dumb because it's a circle. It's like there's no left on a circle, but I think this is the right way. When the whole development process finishes in 15 minutes from code check-in to production, moving left or right a few seconds doesn't really matter that much. So what I'm saying is wait until you have the context to do the testing so that you can be really accurate. And I want to touch on observability really quick. AppSec still has some really hard stuff that people have to do. Penetration testing, threat modeling, risk rating, and incident response. All of those are really hard. You need experts involved. problem is the experts don't have the data they need. What you really need, and this is, I've done lots of all of these activities, what you really need is a blueprint of the application that helps you be really efficient about it. So using runtime security instrumentation, we can build that picture. So it looks a little like this. Imagine you could just run the application and it would automatically keep track of the attack surface, all the entry points. It would keep track of some things about the environment, all the defenses that are in place. Like, hey, this route, reports route, maybe it goes through authentication, then it goes through authorization, then it does encryption, whatever it does. We need to know where the defenses are and how they're used, what dangerous functions are called on that route, and then what services does that route access? Like what backend connections does that route actually access? So now, if, like, let's say I'm doing a penetration test and I want to test for expression language injection. I could either go through all the URLs, all the endpoints, all the parameters and fields in that whole application and try to exploit expression language injection, or I could pull this up, I could click on the thing and I can say, oh, this has 2 expressions in this whole application. Here's the route they're on, here's the parameter, and I could just test them and be done with tremendous amount of confidence that I've tested that whole application accurately. Does it make sense? We can build these security blueprints from applications automatically so that when you're doing penetration testing, it's much easier. Imagine doing threat modeling. Anybody here done any threat modeling? So a couple people. What's the hardest part? Exactly. It takes weeks. What do you use? Like questionnaires and old Visio diagrams? Yeah, and interviews? Yeah, you can spend weeks just gathering the data. How long does the actual threat modeling exercise take? If you had the full diagram. Yeah. That's what we're trying. We're not trying to automate threat modeling. We're trying to automate the data gathering that you need to do threat modeling, because this is hard. You can't really automate, totally automate this. So a lot of really cool stuff we're doing in this idea of security observability. Same thing with risk rating. Anybody question when a tool says a vulnerability is critical? The same SQL injection. Yeah. Well, the same SQL injection, like, imagine it's SQL injection tool is going to say it's critical, right? But what if that SQL injection is on a route that has a access control check that says you have to be an admin? And on the other end, you can see it only connects to a database that you know is read-only. Now, what's that risk? Like low or nothing, right? I mean, so the same vulnerability, we can add that risk context to it to give you a really accurate picture. So I don't have time to go through this. I can demonstrate some of this if you all are interested afterwards or whatever. But I wanted to just close with this. AppSec is in its infancy. You guys can really make a difference. I think the future, if I had to crunch it down into a single phrase, I think the future is where people are only going to use applications when they have a reason to trust it. That's what transparency is going to do to the market. You can easily imagine, restaurants you go to that have a letter grade in the window. Well, software ought to be like that. Right now, it's not at all. You don't know whether the software on the back end is written in Pascal or it's the best, most secure application in the world. Transparency, I believe, is what will change the world. The government is kind of going back and forth between liability and transparency. And I hope they land on transparency, because I think that's a much better endpoint. But your voices matter. So I appreciate you being a part of OWASP. I appreciate you coming to the meeting, and I appreciate you contributing. If there's anything that I can ever do, my LinkedIn is on here. Please feel free to reach out to me, and I'll be happy to try to help with whatever it is you're trying to do. I'd love to have some questions. Yeah, please.
The container environment.
Yeah, I think the question there is whether it's AppSec or not. it's definitely an important problem. Securing a container is more like operating system, host security, server security to me than it is like AppSec, because it's not like code, it's more like configuring products. However, in a lot of ways, it's infrastructure as code. And so I think it's in your repository, it's being managed as code. And so it starts to look a lot more like an AppSec problem. So I think, there's some companies that are kind of on the fence around this issue. And I don't know how it's going to shake out. I really don't.
You guys do you bring anything to the container table?
Nope, not today. We're strictly like language platform and up. It's something that we might do. As we push down, other companies are container companies are kind of pushing up, and they're starting to do things like open source analysis. They're pushing up, and they can see the libraries, so they're like, oh well, we'll report on the libraries that we see. Meanwhile, we're pushing down into the container and saying, hey, we can look at the container components, and I don't know. I don't know where the right place is going to be. Maybe eventually it all consolidates. I really don't know. Oh, sorry, right here. Yeah.
Thanks for the presentation. Orthogonal to the question I was just asked, I was gonna ask for your feedback on container runtime security tools.
Yeah.
And how this might compare. I think you addressed some of that already in your last response, but I wanted to get any other thoughts you might have on that.
Yeah, so some container runtime security tools they're taking a little different approach to a slightly different problem. So they're mostly installing into the container and watching operating system calls. And that's a different vantage point. We think the right place to do AppSec is right in the dangerous methods, not like as a shim between the app and the container, but there are some advantages to that approach. It's language agnostic. So that's good for some things. Like if you're looking at opening files, then that's a good place to be. You can see almost as much as you could see from within the code. But if you're talking about, database connections or encryption or something, those things don't really make operating system calls. So they're going to be very difficult to get insight to from a shim. So it's really just, unfortunately, there's like this gap between containers and apps, AppSec today. Yeah.
All right, thanks, Jeff. We're a little past time here, so I think Jeff said he's going to be able to stick around for some Q&A in the room if he's
I'd be happy to.
available. But thank you all for attending, and once again, we have the happy hour in April, and also we'll have another chapter meeting at the end of April. Sorry, I don't have the info, but thanks again, Jeff, for doing this, and see you all next month.